So diatomic elements are elements that exist when they're in their pure elemental stable form. They exist as small molecules made of two atoms. So it's important, it comes up all the time in the IB exam that you know which seven elements exist as diatomic molecules. So in the periodic table, they're more or less conveniently located together, with the exception of hydrogen. The seven elements are here. So we've got hydrogen up here, and then we've got nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So essentially the halogens plus oxygen and nitrogen and plus hydrogen. So if you're trying to remember those, there are a couple different mnemonics. My chemistry teacher told me that his chemistry teacher was named Miss Brinkelhoff. So Brinkelhoff for bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, fluorine. And what does that actually mean? It means that all of them will have small subscripted 2's when we talk about them in their normal elemental form. Okay. So this doesn't mean that the only way they can exist is as a pair. In fact, some of them have isomers, like oxygen, for example, can exist as O3. This is something called ozone. So it's another form of oxygen known as an allotrope of oxygen. So they don't always have to have 2's. These molecules can be split apart, but in their normal elemental form, if you read an IB question that's talking about hydrogen being produced by a reaction, it's talking about producing H2. If you talk about the oxygen that we're breathing in that's helping us stay alive, we're talking about O2 molecules. So these elements normally in their most stable pure form as elements exist as small 2-atom molecules, so they're referred to as the diatomic elements. So just as a kind of intro to covalent bonding, these are some of the simplest molecules we're going to see. You should be able to figure out how many bonds they're going to form in order to have full stable octets of electrons. These are covalent molecules, so they're going to be sharing electrons. Hydrogen has one valence electron, which means it needs to share one more valence electron in order to feel like it has a stable outer shell of electrons. So each hydrogen can contribute one electron, and if they can share those two electrons together, they form a single covalent bond. So a hydrogen molecule has two H atoms with one single covalent bond, one electron pair between them. The halogens are also going to look like that. So one example would be fluorine. Fluorine has 7 valence electrons, and so that means it needs to share one more electron in order to feel like it has a full stable octet. So here's another fluorine, and so there are their unpaired electrons. So they just need to make one shared electron pair, one covalent bond will make a fluorine molecule stable. Some of the other ones need to make more than one bond. So all the halogens, bromine, iodine, chlorine, and fluorine will look like this, more or less, with different symbols. Hydrogen also makes single bonds, but oxygen and nitrogen are a little bit different. Because oxygen has 6 valence electrons, it needs 2 more in order to feel like it has a stable octet. So there it is. So an oxygen molecule actually has to form a double bond between its two atoms in order for it to, my eraser here, that's my eraser. Whoop, that was a lot of erasing. In order to feel like it has a full octet. So an O2 molecule is 2 oxygen atoms with a double covalent bond, so 2 pairs of electrons are being shared between these 2 oxygen atoms. So this double bond is going to be stronger than any of the single bonds. The more electron pairs involved in the bond, the more attraction between the nuclei and the shared electron pairs, and therefore the bond is going to become shorter and stronger. And so then the last one, the last diatomic element is nitrogen. Nitrogen has 5 valence electrons, and so that means it's going to need to share 3 more in order to feel like it has a full stable octet of electrons. So nitrogen atoms usually form 3 bonds. So when you have an N2 molecule, the 3 bonds have to come from one another. So a nitrogen molecule, an N2, is N triple bonded to N. This is the most covalent bonds that you can have between any two atoms. And so it's a very strong, very short bond. N2 molecules are very, very unreactive because this bond is so strong that it takes very special circumstances to make it break apart. So there's 3 electron pairs, 6 electrons being shared between the 2 nitrogen atoms, and each nitrogen still has 1 lone pair. And so this is what an N2 molecule looks like. So I will expect from now on you work on remembering and memorizing that these 7 elements, when they are in their normal elemental form, exist as diatomic molecules. They don't always have to exist that way. They can exist in compounds in any number of ratios, but when they are in their pure elemental form, they normally exist as diatomic molecules.